since I'm short of time, this is already like one I've kind of worked on. So this is the Claisen reaction. I'll just talk through these reactions and I won't write. So essentially you deprotonate, this makes an enolate. This is kind of very similar to the aldol. But when you go and you attack the second one, what happens is instead of protonating this oxygen and getting the elimination to make the alpha beta unsaturated carbonyl, you kick off the other ethoxide and you make this acetoacetic ester in this case. Then you deprotonate this, and this is the driving force. So this pKa right here is about 11 versus this pKa is about 25, and the pKa of ethanol is about 16 or 15 or whatever, right? So this is driven by pKa. This last deprotonation is what drives the reaction forward. All right, for the second one, what do we do with this? Why do we care? Well, when you deprotonate this is nucleophilic, and you can choose what alkyl groups you get here. So it's like you deprotonate, alkylate. And then at the end, you can do decarboxylation, right? And so you can hydrolyze the ester over here to a carboxylic acid and decarboxylize it to make this. So that's why we care. You can control the functional groups, and you basically end up with the acetone backbone with adding whatever alkyl groups you want to it. All right, and then for 3, not further, you can deprotonate. You can make a ring if you have something like this that has 2 halogens on it, and then you can decarboxylate and only end up with a ketone with a ring on the end. So this is like a great way to make organic rings as well. All right, for the rest of these, we'll walk through the problems as normal. So again, with step 1, we're gonna deprotonate. Step 2, we're going to alkylate. Step 3, oh, I'm sorry, this has an OET here. This is a typo. Otherwise, this one doesn't work. Step 3, we're going to hydrolyze and decarboxylate. So this is going to be like cut off that right there. Step 4 is Fischer esterification. Step 5 makes an enolate, and I'm going to draw it this way. 6 is going to go with it. One, two, three, 4. Here. So since there's only one ester in this solution, it's going to react with itself, which is where you get these 2. And it would deprotonate in step 5, this alpha carbon here, and step 6 is just going to reprotonate it. So that's how that works. All right, 5. Step 1, you're just going to deprotonate. Step 2, we're going to do conjugate addition or 1,4 addition. So you're going to get 1, 2, 3. Right, actually, oops, sorry. 1 and 2 should go together. This should be like 1, 2. That's also a typo. So this is like beginning, you get to here. And then this is Robinson annulation. So we're gonna eventually move, and you're gonna make this 6-membered ring. Something you can do, or you can look in your lab notebook, they have the mechanism for that. And you're gonna make this 6-membered ring here. And then step 2 is you're gonna hydrolyze the ester and you're gonna decarboxylate. Like that. Good. All right. For 6, this lithiates are going to do carbonyl addition. So you're going to add it to this carbonyl carbon. LAH also reduces the carbonyl position. For the HCN now, this is going to do conjugate addition. So you're going to get this as your product, right? And enolates also do conjugate addition. I guess this would be here because I don't have a another thing to protonate that. So I'll just leave this here like this. Finally, we're gonna have two syntheses. The first one's going from here to here. And essentially what I want you to see is this is like a Robinson annulation, and I'm gonna have the top part here, which is gonna be acetone. And then at the bottom part here, what I need to make is, this is gonna come from acetone reacting with this, right? So I need to get this and this, and I need to only use this as my starting carbon. All my carbons are gonna come from this acetone, right? So how do I turn acetone into this? That's the question, right? So I think there's a couple ways I could do this. I could use Br2, what's this? KOH. I'll get the carboxylate, right? Now I can use you could use LAH from here, lithium aluminum hydride. You can go back to the carboxylic acid if you want. Get the ethanol, and then from ethanol I can use PCC. Get the aldehyde. From here I can use like LDA. Get my enolate, and then I could add like a methyl bromide, and I'll get to this. Maybe I don't want to do that. Maybe I want to cut a carbon off. No, I don't want to do it that way, sorry. I want to do it this way. Hold on to this. This will be used later. And then also if I use Br2 and excess KOH, I'll get this, right? This I have to reduce lithium aluminum hydride. That'll make it methanol, and then I'll just add a PCC. And what it will do is it'll make it this, formaldehyde. This and this can do an aldol together to make this. Right? And then when I make this, I can react it with here, and this can just be KOH. I'll get to the final one. So this is kind of a long synthesis, but you can make it work. There's probably a faster way you can figure out how to do it. And I think there was a faster way. I'm just forgetting what it is on the top of my head. But now if I want to go from this to here, this is going to be like a Claisen type reaction. So I'll use OET minus, and what I would get is minus. Okay, I need to put a methyl group here, and then I also need to have a ring. So what I'm going to do is, I guess I'll put on the 1, 2 carbons. First. Right? Then I can use like a bulky base. Maybe like LDA. It's really bulky. That'll deprotonate this carbon over here, which will then attack there, and I will get this. From here, I can just use like a ethoxide. Here, and then I can just use like methyl bromide. And then I can just use H3O plus and some heat, and you'll decarboxylate that off. So there, that's how that works. And that's the end of this worksheet.